might have to spend some time figuring out how to say this properly. So today we are watching Topographic Mapping by Photogrammetric Methods. Topographic Mapping by Photogrammetric Methods, 1947. This should be interesting, I hope. These are all interesting, but Topographic Mapping by Photogrammetric Methods, 1947. So we're going to learn how to map topography using the methods being used in 1947, which were photogrammetric methods. So I don't know exactly what that means. Photogram, that kind of just sounds like a photograph if you ask me, but I guess we'll find out. Yeah, let's see. Yeah, I guess that's all we have to go on. So nothing left to do but start. Wow, look at these instruments already. Are these cameras? Interesting. So I think we are taking photos. Maybe we're taking like photos from different perspectives to map in 3D or something. That would be really sophisticated for 1949, but I guess let's say. Yeah, we have multiple cameras at least. This music is so upbeat too. It's like I feel like we're skipping down like Main Street or something. Whoa, so this is like a very complex machine. I was not expecting something this complex to be from 1947. I mean, I guess we invented the atom bomb already, so a little, like robot isn't that impressive. But it's just like, again, I don't even know what's happening, so let's just. Yeah, it's just shots of different like machines and cameras with music overplayed. Like I really hope there's narration eventually. Oh, this is cool though. We're seeing like rapid photos being taken. Is this Manhattan? Is that what I'm looking at right here? I think this is Manhattan. I think this is like a map. Maybe not. It looks kind of like Manhattan though. I hope we get this shot again explained to us later. Wow, interesting. So they had all that, and now we're getting the U.S. Department of the Interior, March 3rd, oh no, maybe that's just when the department was founded. So U.S. Department of the Interior put this together. Interesting. Again, is this propaganda or is this just like educational video? I don't know. I don't know what the purpose of propagandizing topographic mapping would be, but let's just watch. Okay, there we go. There's the title again. Topographic Mapping by Photogrammetric Methods. I need to hear them say photogrammetric because I feel like I'm saying that.
One of the major responsibilities of the
Oh man, the audio is like hard to understand. All right, well, we gotta listen real close now.
United States Geological Survey is the preparation and maintenance of a series of topographic maps which will cover the entire United States.
Okay, so they're trying to make a series of topographic maps that'll cover the entire United States. A good goal to say the least. I'm here for this sort of thing.
One of the most useful maps produced is the standard quadrangle map.
The standard quadrangle map. That's so funny because I'm sort of familiar with that. So you just pick a very specific part of land to focus on, and then you just create like a rectangle with high data, and then you piece every quadrangle together to make the full map. Interesting.
Bounded by 7 1/2 minutes of longitude and latitude.
7 1/2 minutes of longitude. I hope you guys are taking notes because these numbers are going to come up later, I think.
Of 1 to 24.
They're not. But still take notes.
At a scale of 1 to 24,000, or 1 inch equals 2,000 feet.
1 inch equals 2,000 feet. That's a pretty good scale for a map.
Topographic maps record the physical characteristics of the terrain.
It's funny how they say topographic, though. Topographic. I wonder if that's an old thing versus a new thing, or if I'm just not saying it properly, or if he's not saying it properly. I don't know.
As determined by
I've always said topographic, though.
Precise engineering surveys and measurements.
Wow, okay, so this is an old 1947 topographic map. Interesting.
The brown contour lines, the distinguishing characteristic of topographic maps, show the shape and elevation of the land surface.
Shape and elevation of the land surface. Yeah, nothing new I'm learning here. I'm not learning anything new here so far.
Valleys are shown by the contour symbolization. Rivers and streams are shown in blue. The works of
What city is this? It almost looks like it's saying Wichita or something. I don't know. I can't read it. This kind of looks like Chicago, but it's not on a lake. I don't know. I'm just so curious.
man and the names given them are shown in black. Man-made objects are shown with representative symbolization. The early map makers sketched the terrain in the field.
Yeah, it's so funny to think that maps used to just be like hand sketches as close as they could get. Like, I feel like this is like the first generation of like actually reliable maps used on like based on data, not like based on, you know, like a person's perception of a valley, you know, like this is probably the first time you got like a 1-for-1 relationship between all of the points on a map or something.
Using instruments that made measurements on the ground.
Probably so satisfying for map makers too to finally have a method that actually lets them like draw things accurately. I can only imagine the frustration when you just can't figure out how to draw a valley where it actually makes sense.
From which distances and heights could be determined.
I like seeing all these old instruments though, like these sextants and what have you. Like, I wish I knew how to use these sorts of things. I obviously don't, but like it seems so valuable at a time to be able to use these sorts of things. Again, I wish I just had a use for them by being on a boat and needing to find my way back home. But I guess like without that, there's no real need to know how to use a sextant.
With the development of photography in the mid-1800s, cameras were designed to take terrain photographs.
I like how they have to specify like when cameras were invented. Like we're so close to the invention of cameras that people are still like shocked by it. You know, like we're still talking about, oh, the invention of cameras was just the other day, you know?
Accurate
Like no one would ever mention when cameras first came about in a thing about topographic mapping today. You know, it's only because we're watching this from 1947 that they have to actually like illustrate that cameras were invented recently.
Which accurate measurements could be made. Soon, cameras began to be lifted into the air. Instruments capable of making
See, that's so funny too. Oh my God. I thought they were using like helicopters or planes, not hot air balloons. That makes this like even funnier. What an old like steampunky thing to be doing is taking your huge film camera up in a hot air balloon to take pictures of the ground. Again, like this must have been so satisfying as a map maker, but also like just what an endeavor. You know, it seems like a lot of fun though. Honestly, this was probably like such a fun job.
Measurements from aerial photographs were designed, and photogrammetry developed rapidly.
Photogrammetry. Okay, now I know how to say it. Photogrammetry. So that is probably the piecing together of photographs taken from the air in order to create a larger map. Interesting.
Photogrammetry means obtaining...
That's probably why I haven't heard the term photogrammetry, is because we don't do that anymore.
Photogrammetry means obtaining reliable information about physical objects.
Yeah, just getting this view, oh my God, I can't imagine. It would be like, oh, like you can actually show people what the features look like. Like it must have been so satisfying to do this.
And their environment by measuring and interpreting photographs.
That's crazy to think that like somewhere in a vault somewhere in the US, these photographs are still in existence probably, and they like, I don't know. Isn't that just crazy in and of itself? But like we have all these photos from up above America. Like we could look at like how cities developed using these photos and everything. I'm curious where these photographs are now. I really hope they still exist somewhere.
Today, photographs are taken with high-precision aerial cameras.
Because there's so much information stored in like what the surface of the Earth looked like back then compared to what it does now. Even in terms of like the size of forests or like green vegetation cover versus desert. You know, like you could tell so many things using these photographs still. Again, it's sort of like these programs where the information stored on those photographs is still like equally pertinent and equally as useful as it ever was. It gives us an idea of what this country looked like 100 years ago almost. It's crazy to think that we could compile like an almost satellite view of the US from like 1940. I know it's not a satellite view, but it is effectively the same thing. It's images from above.
And most maps are compiled by stereophotogrammetric methods. After an area has been authorized for mapping, the planning and procurement of photography are the first steps in the mapping process.
So was there just like at one point in history, like balloons over the US taking photos of everything? Was that like a year that like the USGS just had to explain to everyone? I mean, 1947 weather balloons? Oh man. Oh, I don't know. I'm starting to think like that. It just things are making sense. The gears are turning in my head. Hang on, what was that? A request for new/existing aerial photography. Can I fill out this form still? Can I submit this to the U.S. government? Can I submit a request for new/existing aerial photography? I only want the existing aerial photography, but if somebody could get my hands on this piece of paper and tell me where to mail it so that they would give me these photographs, I would love to know that.
Mapping process. The necessary calculations are made on a flight design worksheet.
It's crazy that they had to make calculations too, like because of the lens and where you are and like the angle you're taking everything. Like it seems easy to take photos of the Earth and just piece them all together, but then you realize how much the photographs distort the image and you realize, oh my gosh, there's so much more math involved than what you would imagine.
The flight planner chooses the best available base map on which to delineate the designed flight lines. The final plan gives a location.
Dang, so these are the flight lines. So that's what you would do. You would highlight a quadrangle, or you would pick a quadrangle to focus on, and then you would plan these flight routes that would just go straight parallel to the area, back and forth, almost like you're mowing the lawn or something, to get like scans of it all the way. That's, again, incredible. That's what makes watching this sort of stuff so interesting. You get to see like the behind the napkin work. This guy's lines go over the edge. It doesn't matter. Like this is the actual work that led to the product that we'll see.
Length and spacing of flight strips. The distances between exposures and between flight lines expressed as ratios. The focal length of the camera.
The focal length of the camera, that's what I'm saying. Like they had to think about every single different aspect of this in order for it to all work together. And there was so much math that went into it to figure it all out.
And the heights above sea level for the various flights. The photographs are procured from qualified private contractors.
Qualified private contractors, that's interesting. So the photographers aren't actually U.S. government employees. This is just like a camera company that they hired to do this. That's America for you. That's a private company doing something that the government needs to get done. But I don't know. That's an interesting way of getting that done.
Who use precisely calibrated aerial cameras that meet rigid specifications.
They always say stuff like that in like old-timey programs that meet rigid specifications. Like they'll never explain to us what the specifications are, but they always say stuff like that in these old programs. They meet rigid specifications. Like what specifications? Like why are they so rigid? We don't know, but they always include that sort of detail. I don't know. Like again, it's like there's no point in saying it if you're not going to explain it, but they just wanted to say it, so they did. You know, I don't know. Like in today you would never write a script like that unless you had a reason to say that they're so rigid, you know, unless you had a plan for explaining why. But in this, that's just like a throwaway comment. Like, yeah, very rigid specifications, next thing.
The flight plan must be followed with care, and specified altitudes must be maintained.
Yeah, it seems so impossible to do this on a balloon, too, because you have, like, no method of actually steering yourself, right? Like, that's why I thought they'd do it with, like, a plane or something. This is 1947. We had planes. Like, I don't know. I just feel like a balloon was not the right tool for the job. Seems like a lot more fun, though.
Photographs must be taken when there are no clouds, no snow, no excessive shadows, and minimum foliage.
That is funny to think that they needed to account for clouds and everything. Like, what do you do if you get up there in your balloon and there's clouds? You know, like, I guess this probably took a lot more time, too, than you would expect. Probably a lot more flights and everything. It's just funny because I feel like no one ever heard about this sort of stuff happening. Like, no one in 1947 was aware that there were government balloons taking pictures of the entire country so that we could map it. Or at least I don't know. At least I don't feel like anyone was aware of that. Maybe we were made aware of it from UFOs and that sort of stuff, but I don't know. This all seems like it just happened without anyone making a remark about it whatsoever, which makes it all the more impressive, you know?
The proper aperture must be set. The forward overlap between successive photographs must be carefully monitored to ensure adequate stereo coverage.
Adequate stereo coverage, just like the terms they use. Like, I know what he's saying. Like, obviously you don't want overlap in your images. Well, I guess obviously you want a little overlap in your images so that you can actually align them properly, but you don't want too much. It's just funny, like stereo. What did he say? What was that term? Adequate stereo coverage. Like, I don't know. Just say that the picture's right, you know? Like, I don't know what stereo coverage means.
Upon completion of the
It's too complicated to work out while also just watching.
photography, the film is developed and inspection prints prepared and checked for compliance with...
Dang, this is crazy. So these are the film prints of like the actual photos. That's awesome. I hope we get to see better views of them than just what we're seeing right now, because I am curious what these photographs actually looked like.
with specifications.
Right now, they just look like dark blotches, like I can't see anything, but I'm sure if you actually take like a magnifying glass to them, you can see really cool details.
Forward overlap,
Oh, see, they do overlap. That's what I said.
side
Dang,
overlap.
look at all these. Oh my God, this is crazy. So I wonder how many photographs they needed to map the entire country. This is just insane.
Overlap,
Dang, and yeah, they have like, oh man, that's so nuts. This is, oh, and we got a magnifying glass. Okay,
and
cool.
image quality are checked.
That's so funny. I guess we didn't get to see it that well, but it's funny that like they did have people taking literal magnifying glasses to these photos.
Upon acceptance, horizontal and
Again, to think, before we had these photos, we just had like no actual way of knowing what anything actually looked like. Like, it's just like this is the very first time we had like one-to-one data-driven maps of the world.
horizontal and vertical control planning begins.
So like it must have been interesting to study things from above for the first time, you know, to take a magnifying glass to a photograph of the planet taken from like, you know, 20,000 feet or something. Like you could discover like a whole town that you never knew about before from doing this too.
The centers of the new
I
photograph
guess, you know, it must have been so curious because this is the first time people saw like rivers like this, like meandering. This must have been such an era of like discovery.
graphs are plotted by correlating the imagery on the photograph with the base map detail. The distance between photo centers represents the overlapping portions of
Okay, so hang on. Now they have a plane for this, which makes a lot more sense, but they had a hot air balloon for the other diagram, so I'm kind of curious what they actually used. A plane makes a lot more sense, though. I think that's what I'm going to assume they actually used.
two successive photographs. The topographic map will be compiled from the three-dimensional optical model.
Three-dimensional optical model. See, that's crazy, is that like they knew that they were taking these from different perspectives, so they were going to get like 3D information and that they were able to use that to actually bake down the data into like a flat map. It's just so complex. Like I know I do mapping on my channel, but like nothing like this. Nothing as complicated as this.
And a stereo
And these guys were just figuring it out. Maybe that's what's most impressive, is that like this was happening for the first time. They weren't like basing their work on somebody else's work or or some other like country's work. Like this is the first time anyone was ever doing anything like
formed
this.
and a stereo plotting instrument from the overlapping areas of the photographs. Each stereo model must have corner control points to establish accurate
Corner control points. That's, you know, I didn't say that exact phrase, but yeah, they need at least some information on the edges in order to align it with the other images. If you just took images of just, you know, their specific spots and had no overlap, you wouldn't be able to line them up properly.
to establish accurate scale and elevation, and to
It
reference
must have been frustrating, though, to take this big of a photograph but only have like one small square of it actually useful, you know? Like, I don't know. I mean, you obviously don't really care if you're just doing this as your job, but it must have been like, I don't know, it just must have felt like you were only using a very small part of what you were actually taking photos of.
the stereo model to the map projection, which represents a portion of the surface of the Earth. The rays show the relationship between the control points on the ground, their images on the photograph, and the camera. The basic framework of existing control on the project is delineated.
Again, such complex language they're using in this. Like, they really didn't need to use that big of words, you know?
The plotted centers of the new photographs define the flight lines. The location and density.
Man, I'm glad we're getting to see like the down and dirty, like actual drawings that they would use to plan these flight routes, though. This is actually interesting because you think it's such a complicated endeavor that you would need like complicated instructions, but the only instruction that they give is just like this box with lines through it, you know?
Of the additional control points, which must be surveyed in the field, are indicated by the control planner. This framework will be expanded by photogrammetric methods to develop the model control points shown by the small green symbol.
I like how they specified the color. Oh, you know what? I forgot that this actually isn't in black and white. It just feels like it's in black and white, but I guess maybe once upon a time you were able to tell that those were green. Not anymore. This looks black and white to me.
The field control points
even this, greenery looks black and white to me.
Selected must be field identified for use by the...
Again, is this in color? Yeah, it is, from 1947. See, that's the crazy thing, is I've watched things that are in black and white from like 1965, and then I'll watch things from 1947 that are in color. So I don't know. I don't know what to think of any of that.
The photogrammetrist. The best identification method, called pre-paneling, is to set panels around an existing control mark before the mapping photographs are taken.
No way, really? This is how they would like track everything? Like, I know tracking points in like images is really important, so that's just so funny. They would actually lay down physical like markers with like texture on them so that you could line them up to the next photograph. This is nuts. I wonder if like, I don't know. I wonder if there are any more of these just like left randomly about the country because nobody like picked them up afterwards or something. It's just like, how many of these did you need to set up in your aerial photography so that you could line up everything? It's just, this is such a big operation that, again, I feel like nobody ever even noticed took place.
Using a material which gives maximum contrast between the panel and the ground.
Maximum contrast, just a white sheet. I wonder if it's actually reflective or if it is just a white sheet.
The control point is identified by the panel image on the photograph.
Dang, they're gonna zoom into this image. This is what I wanted to see right here, like the actual like resolution that they were taking these photos in.
This gives the photogrammetrist a positive identification.
Oh, I can't even see what they're talking about here.
And a precise location of the control mark.
Oh, I can sort of see it. Dead in the center, there's that little thing. Oh man, I don't know. I don't even know if the people watching this can see it, but you can barely see the little triangle structure thing that he just laid out.
The planner symbolizes this as he plots and labels the existing horizontal and vertical control points on both the photographs and the control plan. The plan showing the additional ground control points is sent to the field.
Hang on, so is this the thing that they're using to take these photographs? This helicopter? Oh my gosh, I'm so confused now because they showed us a balloon, then they showed us a plane, and now they're actually showing us a helicopter, which maybe a helicopter is the best thing for this because you need to like hover in place and take a photo. Like if you're in a plane, you're going to get like, I don't know, you're going to get smearing if you're taking photos from a moving plane. Maybe not a lot, but like enough to make mapping perfectly accurately difficult. So I guess it makes more sense to use a helicopter than even a plane. But again, is this actually what they were using? Looks like a sick helicopter though, like just a glass dome helicopter. They don't make things like that anymore either, I don't think.
Field crews established elevations and positions for these additional control points. The use of helicopters for the transportation of men and equipment has greatly reduced the time required.
The use of helicopters for the transportation of men and equipment. So they're not using these for the photos. They're just transporting the people to the photo spots, right? I don't know. I don't think they make helicopters like this. I'm not up to date on my helicopter engineering or anything, but like a glass dome with just like a rickety, empty tail of like steel scaffolding. I don't know. I have not seen a helicopter like this ever. But it looks like a lot of fun. Like this glass dome looks so much fun to fly in.
To carry out field survey operations. The electronic distance measuring devices achieve a high order of accuracy for the measured distances in the field control network.
Hang on, so what are they using these boxes for? They're measuring... Are they measuring where the helicopter is? I don't know. It's very complex operation here, I guess.
The photogrammetric operations which follow depend on the accuracy of this basic framework of field control points. In addition to establishing the control points, the field party identifies and classifies the features to be shown on the map. Names for geographic and cultural features are obtained. Control points which are not pre-paneled.
Hang on, I want to see what these names are real quick. It says Nava and then it says Indian. So this is like, I don't know, are we looking at like the Navajo like Indian Reserve or something? Are we mapping like Arizona? I don't even know. We're mapping like somewhere in like the arid Southwest, I guess, probably, based on this. The Navajo, that's interesting.
Control points which are not pre-paneled also must be identified. One method is post-paneling. The control marks are paneled at the time the additional points are surveyed.
Okay, is this the plane that they use? I think this is actually what they're using for these photographs. Maybe I could be wrong, but like, I think we finally figured it out.
An airplane is hired locally.
So they wouldn't even have like an expert pilot who had done this all the time before. They would just hire out like the nearest local pilot. That's so funny.
Panels are photographed.
Again, that's a very American thing to do, I guess.
And these panels are photographed on 35 millimeter film from a flight height selected to give an adequate scale and coverage of the area around the panel. The use of natural panels is a...
So is this footage from one of these planes? This is awesome. See, this is like, yeah, bird's eye view perfectly. That's the whole point, I guess, that it's bird's eye view. But it's like, this is cool. I'm glad we're seeing this.
Common solution to the problem of controlled identification. Natural panels, such as road intersections and small bushes which are imaged on the photographs, are identified and located by precise field surveys. Upon completion of fieldwork, diapositives, which are positive photographic prints on glass or film, are prepared.
Diapositives, which are positives prepared on glass. So it's just the picture, but on glass or something? Interesting.
Diapositives are made under darkroom conditions.
Diapositives. I wonder I don't know. I feel like I don't quite grasp the purpose of the diapositive yet.
Usually in a projection.
Look at this guy. I want to just spend some time looking at this lab technician real quick. Now, I don't want to say anything, but this guy kind of looks Asian, which is cool. Again, I don't know if you all appreciate when I do that, but it's just like, it's so interesting seeing the different sorts of Americans that were in like this government workplace back in 1947, you know? It's nice knowing and seeing that there were just like, I don't know, like Japanese Americans working in like these super secret government facilities too. It's like, it really is like that image of diversity that like we've all been taught about, you know? It's like, it's actually seeing that in play here. I don't know if that's just me, but it's just like, I always expect these to just be just like the whitest guys, you know? Like 1947 America government film, like, I always assume it's just going to be white guys. So when it's not, it's like, it's a pleasant little surprise, I guess. It's a reminder that America has always been this like amazing melting pot.
Printer, which is basically a high precision ratio camera. This printer, filmed under lights, uses an automatic electronic velocity modulation type of photograph.
Hang on, I want to say that whole statement out loud real quick, just because it was so complicated.
This printer filmed under lights.
An
automatic electronic velocity modulation.
Automatic electronic velocity monitor.
Type of photographic contrast control.
Photographic contrast control. Yeah, very complex vocab we're going over today.
A full-size diapositive.
Full-sized diapositive. Yeah, like if the terms alone are kind of throwing me. Freaking shout out to this lab operator again, though. Man, is that a ring on your finger too? Good for you, man.
The printer has several functions.
Yeah, it totally is like an Asian guy too. I don't want to sound so crazy for saying that, but I think it's always interesting seeing who was working for the government back then. I don't know. I think it's interesting is all I got to say.
Compensation for the distortion in the system of lenses in the aerial camera.
It's just like no one is accusing this guy of being DEI, you know? Like this guy is just here based on pure merit. Like the fact that they have a Japanese guy or an Asian guy in this American lab tells us like this guy earned his spot here, you know? That's really the cool part of it all.
The printer and the projector.
Like this guy battled racism, like unknown amounts of racism. Like it's 1947. Like I bet there are still Japanese people getting out of internment camps, and this guy's working in a secret government lab. It's just, I don't know. It's cool. It's cool. Just, I think it's interesting to see what sorts of people were in the U.S. government even back then. And it's nice. It's nice to know that there was always some sort of diversity here.
Correction for Earth curvature, which is a factor at higher flight heights, and a transfer of the primary calibration data from the aerial camera negative to the diapositive.
Yeah, all that jargon kind of just like hit me in the skull and bounced off. I didn't actually pick up on on what's actually going on, but I don't think we need to know that precisely.
The diapositive is developed in film tanks with agitation by the gas burst technique.
With agitation by the gas burst technique. They're trying to make this sound even more complicated than it is. Like you can just say that you're like shaking it up and like blowing bubbles in it. Like you don't have to say like agitation with the gas burst release, whatever. I don't know. It seems more complicated than they need to be. It seems like they're making it sound more complicated than they ought to be.
The development conditions are controlled to produce a diapositive, having a density range which permits the formation of a usable stereo model.
See, like, I don't even want to repeat what he just said, but like a density, oh my God. Yeah, very complex vocab we're using right now.
And accurate plotting. Aerotriangulation begins with...
Aerotriangulation. Again, just some good words, some good long Scrabble words we're using in this one.
Marking the identified control points on the diapositive by...
Marking the identified control points on the diapositive. It's just like, this literally sounds like science fiction mumbo jumbo.
Drilling the emulsion. For projects that were not pre-paneled, the panel positions representing the control points imaged on the 35mm film are transferred to corresponding positions on the diapositive. The framework of field control points is expanded by a photogrammetric process called aerotriangulation.
Photogrammetric process called aerotriangulation. I feel like we already touched on these terms. It's just like, I don't know. Sometimes I try to check myself to see if I'm paying attention and if the words that I'm being said make any sense, but I don't know if that test is really proving anything this time around.
Aerotriangulation develops the required model control points shown by the green symbol.
Which symbol do we think is the green symbol here? Is it the triangles? Are those green symbols? Like, I don't know what green symbol we're talking about.
The planning phase of aerotriangulation involves the selection of tie points which are common to adjacent strips, and model pass points which are common to adjacent photographs in each flight strip.
You know what? This is just making me really appreciate how complex this whole process is. I can only imagine it's even more complex for like satellite imagery too.
Plan points form the framework to fit the models together. The drilled diapositives are placed in high precision stereo plotters. A relative orientation procedure creates an optical terrain model seen in 3 dimensions.
An optical terrain model. Again, it's just like, what even does that mean?
By the operator. He uses the hand wheels and foot pedal to position the measuring mark on what he sees as the ground at the drilled points. The model coordinates of the drilled points are displayed on a console and are punched on a data card.
Dang, this is so crazy. This is like an actual data card. Like, I think they're saving like information to a computer using these cards. I could be wrong, but like, I think that's what these cards are. This is like actually like a byte of information or something. Like you can feed these to a computer and it'll be able to read based on where the holes in the sheet are, and it'll have like a 0 or a 1 or something.
The cards are formed into decks and processed by computer programs.
Yeah, that's, okay, yeah, all right.
Which develop, adjust, and transform the model coordinates.
That's so crazy. Again, this is part of what makes these old programs so interesting. It's just like the technology that like we don't use anymore, that was just like so regular at the time that they like just give you a casual mention of it. It's like, Nobody's computers are saving their information on paper cards with holes punched out of it anymore. That process has been preserved through this film, and we get to see it and understand like how technology used to be through stuff like this. Even though we're learning about topographic mapping, we're also learning about how information was stored on computers, through paper 100 years ago. It's just, there's so much to be learned from all these. And, that's it's part of why I do what I do, is just so that I can see the papers that computers used for information.
Into the coordinate system of the ground control. The output of the adjustment program is a punched card deck of ground coordinates and elevations for all the points to be plotted on the map manuscript.
It looks like so much work still. It's just like, then they have to use that information to plot things on other things. Like, oh my gosh. I hope we get to see like a finished product too. Like that would make this all worth it. But it would also just be so disappointing if we didn't get to see a finished product. Like we learned this whole process and we don't even get to see a map. I really hope we do. I really hope we do.
This deck is processed by another program, producing a magnetic tape.
Oh my gosh. See, so you take the papers and then you have them process the information and then you scan it onto a magnetic tape. It's just like, like how many steps are in this process? Holy moly. And like how many photographs have been taken to this point?
Which provides the input commands for an automatic...
Dang, computers, like this is really just making me appreciate like how complex computers were back then too.
...automatic plotting system called the autoplot.
Like all of this work is being done just so that they can have like data to feed a computer pretty much.
The autoplot automatically prepares the map compilation base by scribing a line to define the geographic reticule.
The geographic reticule, again, just like some really, really good vocab words.
Plotting the state plane coordinate system grid ticks, the basic control points, the photogrammetric control points, along with elevations and identification labels.
So this is just like one big printer. So I think this is the point, right? All that information that they just put into the computer through those cards and whatever the magnetic tape did, I think that's all working towards the purpose of having this thing draw a map using all that information. I could be wrong, but that seems like what we're going with right now.
The data plotted on the map base in conjunction with the data...
Oh man, I really want to see this thing actually draw a map. Like that would be so sick.
...on the photographs provide the compiler with the information necessary to orient the stereo models in the compilation phase which follows.
So that was printing out like the tracking points maybe, and then they're going to put the photographs over that huge tracking sheet. I don't know. It's a very complex operation again. I'll say that.
A double projection type stereo plotter called the ER55 or ballplex.
The ballplex, interesting. So this machine is the ballplex.
Is used chiefly to compile steep terrain. The reduced size...
Oh, is this guy looking through like a stereographic view so that is he looking at like two different images and seeing them in 3D or something? That's possible.
Size diapositives are properly positioned in the holders.
Maybe not. Maybe I'm just fishing that out my ass. But it seems like he's using this for something interesting.
Placed in the projectors and the projector motions used to orient the model. This orientation procedure results in a recovery of the relationship established by the aerial camera at the successive exposure station with respect to the position and attitude of the camera at the preceding exposure station. Terrain with small relief differences is photographed from lower altitudes, and accurate measurements are made from full-size diapositives in optical, mechanical, or double projection type stereo plotting instruments.
Optical, mechanical, or double projection type. Oh my gosh, it's just, there's just so many big words, and I don't mean to be like a dumb idiot who just can't understand big words. Like I know what's happening. It's just like I could not tell you what's happening. I understand what's happening, but I could not write this down for myself.
Some of the optical mechanical plotters used are the Wild A7, which is basically an aerotriangulation instrument. The Wild B8, which has a drawing device.
I like how we're just learning the names of these mapping machines now. Like that's that's what I came here for.
Device in the tracing stand that permits the map to be compiled at model scale or through the pantograph. And the Kern PG2, which also uses full-size diapositives. On this plotter, the diapositives remain in a horizontal position.
So hang on, so they put the diapositive image into this thing, and it looks like he just swung like a light over it. So they're gonna shine light. Are they trying to copy the image down onto like another photo sheet and then like put it all on one master photo sheet? Is that what they're doing? It's really hard to tell because these machines are really like complex. I'm just trying to figure it out before we have it explained to us.
During the entire orientation and compilation procedures. The system of horizontal rails...
Again, it's just so amazing that we had machines like this. Not only is this process so complex, but like the construction of these machines even, like the fact that we knew what we wanted to do with this photography so much that we were able to build a machine so complicated that it can take into account all the different aspects of aerial photography. It's just nuts. It's nuts seeing this complex of technology in application all the way back in 1947. It's just wild. Like, who makes this machine? Is this like a custom machine? Or are they like pumping these machines out on like an assembly line for something? You know, like this seems like it would be like a one-of-a-kind machine. I don't know. I don't know what company would make more than like a handful of these sorts of machines. And it's like, what's the purpose of producing a machine that you only make once? Like, did the company make money off of this machine, or is this like a special machine? I don't know. It's so interesting, I guess. Just like all this sort of stuff that they had back then. I don't know.
Supports the projectors as the tracing stand to which the projector carriages are connected is moved in the X.
Like, this machine itself probably took like years to conceive of and construct, you know, and to get to work properly. It's all so complex.
And then the Y directions in the model.
I feel like humans were just smarter back in these days too. Like, the fact that we figured all this stuff out, it just blows my mind to this day.
These optical mechanical instruments use a train of prisms, lenses, and mechanical motion.
A train of prisms and lenses. Yeah, look at all these prisms and lenses that we got going on here. This is nuts. Like, again, like, how did people even figure this stuff out? Without a computer, without anything but your own two hands, figure out how to freaking map. This is really impressive.
To form the model, which is viewed in 3 dimensions after an orientation procedure.
Again, they can just view it in 3 dimensions too. Like, just amazing. Like this is honestly the sort of science that borders on magic to me.
The Kelch plotter, which also uses full-size diapositives, is a double projection type instrument. The model is formed by conjugate image rays projected from each diapositive onto the viewing platen. A viewing system called a stereo image alternator flashes images alternately from each projector.
Interesting. So it alternates the images it's showing. Is that going to give you a 3D effect or something?
A rotating shutter in each projector generates these flashes. The images are seen on a platen through a synchronized viewing shutter and are so phased that the left image is presented to the left eye.
Yeah, so we are getting like a 3D. That's like another step. Not only are they producing like a real photographic map of the entire US, but they're creating it in 3D in 1947. Like, that's nuts.
And the right to the right eye. The mind coordinates these images to give the operator the impression of a 3-dimensional optical model.
Dude, I want to see, do they have this machine anywhere? Like, is there a museum just in some random town in America that still has one of these running? Because I want to see what it looks like to look through this thing.
A relative orientation procedure arranges the projected images to form the stereo model. The rotational and translational motions of the projectors are used to establish the position and attitude of the pair of projectors with respect to each other. As with the ER-55, the relative position and attitude of the camera at successive exposure stations is recovered by the projectors. An absolute orientation procedure relates the model to the surface of the Earth, as represented by the map base, by means of correlating the drill control points as seen in the model with their respective positions and elevations plotted on the map compilation base.
Yeah, I have nothing else to add at this point. I'm just here to say that, like, this is so impressive. Like, the fact that people knew how to work all these machines in conjunction with one another to get the product that they were looking for. Like, I don't know how many people it took to figure this out, but it is impressive to say the least.
The correlation is transferred from the model space to the map base through a precisely calibrated reduction pantograph.
Reduction pantograph. Like, what does that even mean, man? Is that a band name?
The relationship between model and map compilation base is maintained by metal registration studs taped on the granite plotting surface. The platen, containing the illuminated measuring mark, is connected to a digital counter through a series of gears, which are changed for different model scales. Accurate elevations are read by positioning
Kits and gadgets on these machines too. It's just like, how do you know everything's calibrated right? Like, I have trouble enough knowing that my camera is running, you know, when I'm recording this. But these people, like, keep track of so many little details that affect the, you know, perspective and everything of these images so much. It's so wild to think that, like, so much work went into this.
elevations are read by positioning the measuring mark on the ground.
He's also saying measuring weird. I don't know if anyone else is hearing it weird, but, like, he's saying measuring, not measuring. I don't know. Maybe that's just me.
Surface and the optical model of the terrain. The compilation map manuscripts consist of the map compilation.
Map compilation base. Can we see these? Can we get to be shown something like this?
The woodland base.
The woodland base? Oh, that's interesting. So this is, so they have like streets or something, like the map compilation base. So is that everything? And then they have like the woodlands specifically? That's interesting. Again, did somebody have to go in by hand to figure out the woodlands? Like, there's not a computer you're training to identify the woodlands. Like, somebody's just saying, oh, those are trees, those are trees, those are trees, that's not a tree, you know? Like, what, how do you get the woodland base? I don't know.
And the contour base.
That one seems a little bit more easy. Actually, that probably is like the application of like the 3D viewer, right? Like, you can't actually tell elevation based on a head-on photograph from above. But with two photographs, with being able to tell the difference between them, you could probably figure out the 3D layout of the land, which would allow you to make a contour map. Interesting. If that's how they do it, I don't know. But like that, you totally could do it that way.
These components are registered to each other by holes punched at each corner. Metal studs inserted in these holes permit a precise recovery of the initial registration for...
That's so funny. That's such a simple solution, too. Like, just punch a hole in the paper and line them up that way, you know? Like, some things are complicated, and some things don't have to be.
Any combination of bases. The map-worthy planimetric detail is compiled on the map compilation base by keeping the measuring mark in contact with the apparent ground and tracing out the features. Then the map compilation base is removed from the granite plotting surface, and the pencil planimetry is carefully scribed over a light table with proper symbolization.
So are they tracing things now? They're taking photographs and they're drawing things so that they're all lined up? I don't know. I really don't know what's going on anymore. Why does this always happen on blue videos? I can understand anything else that's happening in these, but sometimes these science videos just throw me for a loop. The fact that we're talking about science that was taking place like almost 100 years ago and it's still like wowing me, you know, that's the value of these videos again.
Special tools called gravers are used to cut out the lines drawn on or transferred to an opaque coating on a sheet of clear plastic. A transparent image is produced.
So they are like tracing these things over like other papers and they're actually scratching away to reveal it being transparent. That's so interesting. That's just like not what I expected, I guess.
And the scribe negative may be utilized in the same manner as a photo negative in subsequent photographic processes. If the terrain contains ground cover, which is to be mapped as one of the classifications of woodland, the woodland base is placed on the registration studs. The areas of vegetation outlined from the model.
Hang on, so would somebody need to outline the vegetation on every single one of these photos to have an accurate woodland base? Is that what he's saying? That like somebody, some poor American had to outline the shape of like every tree from above to get an accurate map? I hope that's not the case. I don't think we would have had so much of a use for that map that would necessitate something like that. But that's what it's sounding like.
and subsequently scribed.
Dang, I thought this was a map of the world for a second. I was like, this is really interesting. But no, it's just like a map of some small plot of America somewhere.
The contour.
I wonder if there's anyone who recognizes where we're looking at right now just based on this map. Like somebody's like, oh yeah, that's like my home valley.
The contour base is registered.
Probably not. This is probably too abstract for anyone to be able to identify. You know, yeah, bonus points for whoever does that homework.
Contour base is registered. The elevation difference of the ground in the model determines the series of contours which will be traced that portray the terrain.
Oh, see, that's the crazy thing is like you need to figure out like the elevation so that you can figure out the contours. And if even one piece of data is wrong or like one dial is dialed up in the wrong direction, like everything would be all off. It seems so complicated.
The measuring mark is set at a contour elevation, and as the operator traverses the model surface at that height, the contour is scribed directly. This is repeated for the range of contours in the model and completes the photogrammetric compilation.
So hang on, what we're watching in this view is somebody trace the dot over the details, and then that is being translated to that yellow piece of paper through that like mechanism or whatever. Is that, am I getting that right?
Of the model.
Dude, I love this guy's outfit too. Like you could wear this today and be completely normal.
The information scribed on the map compilation base, as well as the contours which were direct scribed, are transferred to the contour base by a photographic process. The direct scribe contours...
Oh man, for a second I thought we were just looking at like a blank yellow piece of paper, but no, you can actually see the contour lines. That's amazing. Again, I wanted to see more of this. I wanted to see them in more detail, but I guess this is the best we'll do. I can barely see the lines though.
Must be rescribed. This base provides the final contour reproduction manuscript when cartographic standards are met.
See, look at them making this, right? Like they're carving in, look how detailed it is over here. This is just, I wonder how long this all took.
Otherwise, the contour base is rescribed during the color separation phase.
Oh my God, like look how many lines there are. And they had to do this for like every freaking square mile of America. Holy moly. I wonder if this was all even worth it in the end. Like, did we actually even need to do this? Or did we get like a satellite photo like 20 years later that did all this for us in like an instant?
A composite print is made from the map compilation base and the contour base and reviewed. The compilation is checked not only to assure that the detail annotated...
I like this little tool. I wonder if this lets him see in 3D too, or if this is just like a magnifying glass or something.
On photographs and...
It seems like it lines up his perspective so that he can see them from like a 3D perspective. I don't know if that's true though.
Has been completely and correctly compiled, but also to check whether or not...
Again, just like the little tools that people used to have to do tasks that we no longer need to do. Like nobody would have remembered the little sightseer, map viewer thing, but because it was filmed, it's always been remembered now. Again, another just aspect of these old films that's been preserved through old films like this.
Map the contours appropriately depict the shape and elevation of the land surface. The materials are then sent to the Field Surveys branch for completion of section line detail and further checking. Then to the branch of cartography for color separation and editing.
Dang, color separation? Like somebody had to color this all in too, and they were using black and white photographs, so I don't know how they did that part, but that's just another aspect that I just did not think about.
The color separation manuscripts are sent from the regional facilities to Washington, D.C. for printing and publication.
Wow, look at these. These do look like USGS maps though. Like if you've ever looked at USGS maps, which I've had to do for my videos a few times, like these are pretty much exactly what they still look like.
The standard 1 to 24.
Wow, yeah, like this is exactly a USGS map. That's so funny. I guess now I know how these were made.
4,000 scale topographic maps prepared by the United States Geological Survey have many...
Yeah, the U.S. Geological Survey. That's what I said. That's I know what I'm talking about again, finally.
Uses as fundamental tools for planning and executing projects that are necessary to our modern way of life.
All right, so these maps are necessary for planning and executing projects that are necessary for our modern way of life. So that's another way of saying, like, this just lets us figure out where we want to build stuff, probably.
Intelligent and efficient development of our natural resources depends on the availability of adequate topographic maps.
That's an interesting argument too, that like our ability to preserve our natural resources hinges on our understanding of how many resources we have to begin with. Very true. That's very forward thinking also. That's also what I love about these old films, is just like how much they were thinking about good things like, resource conservation and that sort of stuff. Like, and they were trying their hardest to use this new technology, this new mapping technology, in order to use their resources more effectively. It's so interesting again.
Thoughtful and intelligent utilization of these resources will make it possible to maintain the delicate balance of life.
The fact like that is the moral of the story, that these maps help us manage the delicate balance of life on this planet. Like what a weird but great way to like make this seem like it's important.
On our planet.
Oh wow, that was the end. So I wonder if this picture of the planet, is that an illustration, you think? Because it's 47, so I don't think we've ever gone to space by this point. So this is probably just a painting of the Earth. But that's probably what they thought they were doing. They were like collecting images of the entire world. And they probably knew that if they did that for long enough, they would have the entire globe mapped. Just funny that they just didn't have that done by this point. They just expected that one day they would have a perfect image of the Earth, which we do now. They didn't have that perfect image, so they just had to use this drawing. That's just a funny way to end this, is by using a drawing instead of an actual map. But this was very interesting. There were a lot of facets of this process that I feel like could have been gone into even more depth, but I'm glad that they didn't, honestly. I think I would have been even more lost if they tried to explain how a machine works, like that's kind of the limit of my brain at this point. But this was very interesting. I think I did understand most of it. I think there was just a lot of very complex like jargon being thrown out that was pretty easy to get lost in, but so long as you just pay attention and watch what's happening, it all kind of makes sense. It's so fascinating that this is the old mapping technology. Like today we don't have anything like this. We just have like Google Maps and like satellite view, but back then they had to do it all by hand. And I guess like this is it happening by hand. That's just, I don't know. I guess this is just a reminder that technology has come very, very far in a very short period of time. I'm very glad with the way that ended, though. It actually put a good context or a good spin on all this work. It actually made it seem like there's a purpose behind it beyond just curiosity. Like we actually need to know how big our forests are so that we can know how much to extract versus keep so that it stays a healthy forest or something. Like there are good applications of mapping. I mean, I guess that's the whole point of like Atlas Pro in my channel, is that you can use maps for very good purposes or very bad purposes, I guess. But it's nice to hear that that's the angle they were trying to spin with this, is that this mapping would enable us to protect our natural resources a lot better. I wasn't expecting that, but it's a very nice thing to be hearing, especially back in 1947. I wonder if it's actually true or not. Again, this could be just like propaganda or something, but I like to think that we actually did use these maps in order to protect our resources more so than to extract them. Again, I could be wrong. We could have used these maps to discover new resources to exploit, but I don't know. I don't know if I really need to go down that route today. But overall, very interesting. I feel like I know more about mapping than I did before, I guess. Like, I feel like this is a whole, like, lost art of mapping that I've never had to interact with before, but, like, was once so essential in creating our images of the world. Like, I bet some of the atlases I have back there, like literally right there, were probably formed with some of this information in mind, or used some of this information at the very least. But I could be wrong about that, but I feel like this is like the very start of mapping having data rather than mapping using your visual cues. Like this is the start of data-driven mapping for sure. With that, I think that's all I have to say. So if you enjoyed what you watched and would like to help support what I do here, go to the link in the description and give the Internet Archive a big old donation. They deserve it all. That's where I get all these videos from. So if you would like to help support me and this channel, all you got to do is donate to the Internet Archive. That's all I ask of you, and I think with that we are done. So let's just cut to black.